Hi, we are OP Team RedBack, a dedicated group working on the OPTIMA project. In this video, we are going to show the progress we've made so far. The OPTIMA project is aimed at building a centralized data management platform to support optimization and machine learning research. This platform will help researchers organize, store, and access large data sets critical to their research. What we are building in Sprint 2. In Sprint 2, we dedicated 60% of our time to researching and designing the system, including tool selection, architecture design, and database design. While this slow early progress, it was essential to align the project with the long-term scalability goals set by the client. After gathering the client's requirements and conducting extensive discussions and research within the group, we proposed the system workflow shown on the screen, which was subsequently approved by the client. The user interacts with the system in two key ways: uploading data and downloading data. For uploading data, let's start from the left. The user uploads files to MediaFlux, which stores the data. MediaFlux returns a message indicating whether the upload was successful or not. If the upload is successful, the system stores a success message through an API gateway. The API gateway triggers a Lambda function, which stores the success message in a relational database and then returns a success confirmation back to the user. We've also designed the downloading workflow. However, I won't expand on it for now, since it hasn't been implemented yet. The database is also a key part of our architecture design, especially given the variety of data and formats we are handling. The client has approved our database design, which includes 3 tables: users, problems, and instance data. This design ensures scalability and effective management of device datasets. After finalizing the necessary design, we began the implementation phase. In Sprint 2, we focus on 3 key parts: the AWS initial setup, MediaFlux upload function, and CRUD operations on the local database. However, since the connection between these components has not been implemented yet, we are not deploying it this sprint. Next, I will quickly demonstrate the operations we've implemented. This is the MediaFlux Explorer interface, where our team OP RedBack has created a folder named OP RedBack for testing and development. As you can see under the Instances folder, the LKCC Easy folder is not present yet. Next, I will upload the LKCC Easy folder using the command line to demonstrate our MediaFlux integration for file uploads. Our upload tool is command line based, as many users will interact with data for optimization or machine learning tasks through scripts and command line tools. Let's start by running the upload command. Now the system will prompt me for my domain. I will select either student or staff. And then I will enter my university username. Next, I will provide the path to the file or folder that I wanted to upload. By the way, the LKCC Easy folder has multiple datasets inside, since researchers will often be working with multiple datasets for their machine learning or optimization tasks. This tool supports uploading large files or directory in batch. At this early stage, we specify the destination path for storage. However, this step will be hidden in later versions, as users won't need to handle these details. It's currently included for developer testing. Now, I will enter my password to authenticate the session. Once all the inputs are provided, the file will be uploaded to MediaFlux. Now, I will demonstrate how we perform basic CRUD operations on the user table using Postman. This will give you an overview of how we interact with our database through the API. First, let's create a new user. I will use the post method to send the necessary user data to our API. This creates a new user in the database and returns the created user details as confirmation. The created user information was stored on the database as well. In our database, each user is automatically assigned a unique ID when they are created. Here, the user has ID of 1. Next, let's get all users from the database using the GET request. Here, we get a list of all users stored in the database, returned in JSON format. Now, I will demonstrate updating an existing user's name to Ashley. We will use the put method to modify the user's details. And the updated information was stored on the database immediately. Finally, let's delete the existing user from the database using a delete request. And the information was deleted from database as well. That concludes our demonstration. Thank you for watching, and we look forward to demonstrating further progress in the upcoming sprints.